R or I square R into T. So this if you recollect, we use this formula, basically this the Ohm's law, V equal to IR, and if you put that V equal to IR in this equation, that is VIT, you can have these two formula, that is V square T divided by R or I square RT. So any of this formula you can use here to calculate the thermal energy or electrical energy. Okay, so thermal energy, nothing but heat produced in the here in the circuit, is nothing but VIT. So I can use this formula V I and T, VIT. Okay, so we can put the values of the voltage, that is nothing but the 12 volt. The amount of current we have just calculated over here, that is nothing but 2. And the time given, it is nothing but the 10 minutes, and we have to convert that 10 minutes into the second. Okay, we should convert that, and we know that 10 minutes, 1 minute is nothing but 60 seconds. So 10 minutes is nothing but 600 seconds. Okay, so this way we have to convert everything into the SI system. Then only you can solve the formula. So this calculation is coming out to be 14,400 joule, and we have to write this here also, 14,400 joule. Now we will move towards the next problem. So here is the last and the fifth question. A digital watch is powered by 1.3 volt cell. The cell supplies the current of 4.1 into 10 to minus 5 ampere for 1.6 into 10 to 7 seconds. And we have to calculate the following things. The part A is the charge that passes through the cell in this time. So here you can see the current is given, that is 4.1 into 10 to minus 5 ampere, and the time is also given, 1.6 into 10 to 7 seconds. So we can use here the formula of nothing but the direct definition of the current, that is nothing but charge divided by time, because here we want to calculate the charge that is passing through the circuit. So here by definition, the electric current is nothing but charge divided by time taken. So we can rearrange this formula. So here the charge will be equal to amount of current into time. Okay, so if you take this time to the left hand side, we can get I into T. So Q is equal to I into T. Now we will put the value of the electric current and the time. Here the current is given, that is nothing but 4.1 into 10 to minus 5. So 4.1 into 10 to minus 5. And the time is given, that is nothing but the 1.6 into 10 to 7. 1.6 into 10 to 7. Both the values are given, and you have to just calculate the values here with the help of your calculator. And if you calculate these values, you can find the answer. Now if you calculate this value, that is 4.1 into 10 to minus 5 into 1.6 into 10 to 7, it is coming out to be approximately 660 coulomb. Okay, so coulomb is the unit for the electric charge, so we have to put capital C. The same value we are going to write down over here, that is nothing but 660 coulomb. Okay, now we will see the part B of the question, the resistance of the electric circuit in the watch. So here we need to find out the resistance value. So for that we are going to use the Ohm's law. Ohm's law is nothing but the V is equal to IR. V is equal to IR. So we can rearrange this formula here to calculate the value of R. So R will become equal to V divided by I. Okay. So if you rearrange this formula, if you take R to the left hand side, it will become V divided by R, that is nothing but equal to R. So here you can put the value of the voltage and the current. So what is the amount of voltage they have given? If you read this question, you can find out the value of the potential difference, or the potential difference of the cell is nothing but 1.3, and the amount of current is nothing but here 4.1 into 10 raised to minus 5. So 4.1 into 10 raised to minus 5, the amount of current given. So here if you put this value and if you calculate this, calculate with using your calculator, then you can find out this answer is nothing but equal to 32,000 ohm. So the unit of the resistance is nothing but the ohm. So I am drawing here the symbol of the ohm, and we have to write down the same value here, that is nothing but 32,000 ohm. So we are going to use the Ohm's law. Now let's see the third part, that is part C of the question, the output power of the cell. And we know the electric power is given by this formula, that is nothing but V into I. And if you put the Ohm's law, that is V equal to IR in this formula, you will get two more formula, that is I square R or V square divided by R. So any of this formula you can put. I will use the first one, that is nothing but simple one, V is equal to Vi. So I will write down over here, P is nothing but Vi, that is potential difference into electric current. So potential difference is nothing but of the cell, that is 1.3 divided by multiplied by the amount of current, that is 4.1 into 10 raised to minus 5, 10 raised to minus 5. So here you can put this value. Now if you calculate this value, that is 1.3 into 4.1 into 10 raised to minus 5, you will get the answer of 5.3 into 10 raised to minus 5, and the unit of the power is nothing but the watt. So for that you can write down the W. So it is a simple calculation. Now we have to write down the same value here. It is nothing but 5.3 into 10 raised to minus 5 watt. So I hope you understood this problem, and this is our last problem.